All right, here we go. So today, although I am not there with you today, we are going to start chapter 11. So chapter 11 is all about circles. So let's start talking about some different things that we can do with circles. So today we're going to talk about lines that intersect circles. So we're talking about a circle and a line somewhere inside, outside, within this circle. So we're going to talk about three different types of lines today. So the first one is going to be called a chord. A chord is a segment whose endpoints lie on a circle. So if you look at this purple line over here, that would be a chord. If you look at the endpoints of that line, each of those endpoints, where it starts and finishes, are on the circle. Okay, that's called a chord. Okay, the next one, which is probably the most common one I would say, is called a secant. Okay, secant. A secant or secant line is going to be a line that intersects a circle at 2 points. So basically it's a line that goes through a circle and out the other side. So it's going to intersect the circle 2 places. So it goes in the circle and comes out of the circle. Okay, the one we are going to be interested in today is called a tangent line. If this will let me write on here, a tangent. Now, a tangent line is kind of like a secant line, except it is going to intersect the circle at exactly 1 point. So if you look at this blue tangent line over here, it basically touches the outside of the circle. It does not go inside the circle. It's going to cross that circle exactly 1 time. Now, the point where the tangent and a circle intersect is called the point of tangency. This is not liking me today. The point of tangency. So if I look at my picture over here where this tangent line intersects the circle right there at point T, that would be called the point of tangency. Now we're going to have 2 theorems that we're going to be interested in today and tomorrow. So the first one, and this is going to be really very important today. If a line is tangent to a circle, so remember tangent means it crosses exactly 1 time, okay, then it is perpendicular to the radius drawn to the point of tangency. So in other words, this line is a tangent line, okay, touches that circle exactly 1 time. If I look at this point of tangency right here, if I were to draw this radius from the center of the circle to the point of tangency, that's going to be a right angle. So, in brief, tangent line is perpendicular to the radius. That's what you need to know for that one. Okay, the second one is going to come more into play tomorrow, but we'll go ahead and introduce it today. This says if we have 2 segments that are tangent to a circle from the same external point, then the segments are congruent. Okay, so what we're talking about here is I have this segment AB, where B is a point of tangency, and then I have this segment AC, where C is a point of tangency. If that happens, then that means that AB is congruent to AC. So in other words, once again, in brief, 2 tangents from the same exterior point are congruent. We're not going to use that one as much today, but we will bring that in tomorrow. Okay, so here's kind of the main focus of what we're doing today, is we're going to apply basically that first theorem that says a tangent line is perpendicular to the radius to decide if a segment is tangent to the circle. So let's see what this is going to look like here. So let's say we have this circle, and I want to know, is AB tangent to the circle? So if I look at this segment AB, and I'm wanting to know if this is tangent, okay, think about that first theorem. If this is a line of tangency, this right here is a radius. And if this is tangent, that has to be a right angle, which may not seem that relevant, but we have done a whole lot with right angles, and one of the probably simplest, most common thing we can do with a right angle, and specifically a right triangle, is this awesome, incredible thing that we know as the Pythagorean theorem. I know that if this is a right triangle, which I'm not sure if it's a right triangle yet, that's what I'm trying to figure out. If this is a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. So what that means is that if this is a right angle, this squared plus this squared would have to equal this squared. Remember, A and B are the legs. C has to be the hypotenuse. So what we're going to do is plug these into the Pythagorean theorem, and we're going to see if it works. So if I take 8.4 squared plus 11.7 squared, I should get 14 squared. We're just checking. I'm not sure if it's true yet. We're just checking. So 8.4 squared would give me 70.56. 11.7 squared gives me 136.89. And 14 squared gives me 196. So still not quite sure if those are equal, but what happens here is if you add these two numbers together, you get 207.45, which unfortunately does not equal 196. So what that tells me is that this is not a right angle, which means this is not a tangent line. Okay, let's go ahead and let's move on to examples. You can glue this in at the very end here. So we're going to do two main things on your homework today. So the first thing we're going to do on your homework today is we are going to look at a circle just like we just did, and we are going to decide, is AB tangent to the circle? So let's draw our picture here. So we're going to have a circle. We'll have a center point of our circle out to point A. So that's going to be point A. Okay. Out here, we're going to have point B. Okay. So AB is what we're checking if that's a tangent line. Okay. Now in our picture, we're going to have this other segment here. Okay. But what we're wanting to know is if AB is a tangent line. Here's the other information that we are going to know. So let's say this dimension right here is going to be 11.4. This side over here from A to B is going to be 15.2. And then be careful here, from this point to here, just that is going to be 7.6. Okay, so this is going to be the information we're given. Here's how we're going to figure out if this is a line of tangency. So keep in mind, we're checking if AB is a tangent line. Now here's the thing. If AB is tangent, it is perpendicular to the radius. So one of the important things we're going to have to do today is identify these two lines here. What I'm checking, I need to figure out if this is a right angle. And if this is a right angle, it means that this is a right triangle, which means I should be able to take a squared plus b squared, and it should equal c squared. Now the problem is, it doesn't technically tell me what c is. It just tells me this much of c. But if you look closer, this is also a radius. From the center point to the edge, that's also the radius. So guess what? If that's 11.4, that's also 11.4. So that entire side right there, 11.4 plus 7.6 would give me 19. So these are the three numbers that you're going to plug into the Pythagorean theorem: 11.4, 15.2, and 19. Now remember, your A and B have to be the sides that make up the right angle. So we're going to take 11.4 squared plus 15.2 squared, and we're checking, will that equal 19 squared? So if we do some calculating here, 11.4 squared gives me 129.96. 15.2 squared gives me 231.04. And we're checking, 19 squared would give me 361. And this one actually works out, because when you add those two numbers together, you get 361, which gives me a true statement, which means, yes, I know that AB is a tangent line because I know that this is a right triangle, which means that that is a right angle. Okay, let's try one more of these ones. Okay, number 2. All right, so let's draw our circle. Okay, now this time we're going to draw a diameter, so all the way across. We're going to have point A over here, and then point B is going to be over here. So remember, what we're checking is if AB is a tangent line. So we're going to go ahead, kind of, hopefully we're kind of starting to figure this out here, that this is going to be an application of right triangles, or what might be a right triangle. So let's go ahead and sketch out this picture here. So we're checking AB if it is a tangent line. So the information we're going to be given is that length of AB is going to be 10.4. This entire length here is going to be 17. And then from the center of the circle to A, that's going to be 6.8. Now the first thing I would encourage you to do is figure out what angle are we trying to prove is a right angle. So if we look at this one, keep in mind that if this is what I'm trying to prove is a tangent line, if it is a tangent line, it should be perpendicular to the radius. So those are the two things that you need to identify. So this is the right angle that I'm trying to see, if it is actually a right angle, which means I have my A, B, and C, because remember, C is always the hypotenuse across from the right angle. Now I have my A, but this side, notice I only have half of it, but kind of like with the last one. Notice that if this is 6.8, that's a radius, that's also a radius. So that is also going to be 6.8, which means that entire side is going to be 13.6. So we're going to say, okay, is 13.6 squared, one of the legs, plus 10.4 squared, the other leg, is that going to be equal to 17 squared, which is the hypotenuse? Well, 13.6 squared gives me 184.96. 10.4 squared gives me 108.16. And 17 squared gives me 289. So once again, we're still checking. We're not sure if they are equal. When you add those two numbers together, you get 293.12, which is close, but that is not 289. So this is not a point of tangency. Okay, now we're going to kind of take that one step further, and instead of checking to see if it is a tangent line, we are going to say that, okay, we're going to find the segment length indicated. And what we're going to know is that if it appears to be tangent, we can go ahead and assume that it is tangent. So let's try this one. So number 3 looks like this. Let's draw our circle, okay? And we are going to draw, okay, the center of the circle, and we're going to go outside the circle like this, and then we're going to go down, so a radius from the center of the circle, and then we're going to connect those two right there. Okay, and the information we're going to be given, not going to be given much, so we're going to identify this point right here, and then we're going to say that this segment is 7.5, and then this segment is 8.4. We want to find that side right there. So this is what it's going to look like when you get to your homework. So, first thing that I would suggest you do, let's identify the line that appears to be tangent. So remember, a line that is tangent touches the circle exactly once. So it's going to be this one, although my picture is not great. It looks like that one. It says, if it appears to be a tangent line, we can assume that it is. So instead of checking if it's a tangent line, we can assume that it's a tangent line, which means that this line and this radius are perpendicular. They form a right angle. So we can apply the Pythagorean theorem. We can do a squared plus b squared equals c squared. Here's the thing. To do a right triangle, to do a squared plus b squared equals c squared, I have to have two sides. Now, I know this whole side. I could take 7.5 plus 8.4, and you would get 15.9. That's my hypotenuse. I know my c. I don't know this side. That's the side I'm looking for. But I have to know this side. So one thing you're really looking for today is that this is a radius. This is also a radius. So those two distances, those two lengths are going to be the same. So this is also going to be 8.4. Now what we're doing with this one is just a little bit different because I don't know all three sides. We're still plugging it into the Pythagorean theorem. So this is your A. This is your B, which I don't know. And this is your C. So we're going to take 8.4 squared plus, here's the thing, I don't know what B is, so we're just going to leave it as B squared. And we're going to set that equal to C squared, which is 15.9 squared. Now when you take 8.4 squared, you get 70.56. I still don't know what B is, so we're going to leave that as B squared. And 15.9 squared gives me 252.81. Now, the whole point here is to solve for B. So to solve for B, we first have to solve for B squared. So we're going to subtract that 70.56 from both sides. So we'd get B squared equals 182.25. And then that missing side is B, not B squared. So we square root both sides, and we would end up with 13.5. So just an application of the Pythagorean theorem. Let's do one more. So number 4. All right, let's sketch out our circle here. And we're going to draw a radius down here. We're going to draw, that's going to actually technically be a secant line. And then we're going to connect those two right there. This first radius line that we drew, we're going to call that 9. From this point here to the outside, we're going to call that 6. And we are going to be looking for that side right there. So once again, like I've said on the last few, what I would do first is I would identify your tangent line, the one that appears to be tangent, and the radius that it should be perpendicular to. So that tangent line is the one that just touches the edge of the circle and would keep going if I were to extend it out. The radius is going to be that one right there. So that is my right angle. So if I look at this right triangle, we've got our A, B. Keep in mind that C is always that side across from the right angle. Now I have A. I don't know B, that's what I'm looking for. And I have part of C. But I need to find that other missing part of C. But hopefully we're kind of noticing a pattern here. That missing part of C is that radius, which I already know is 9. So this entire side, that entire hypotenuse, 6 plus 9, is 15. So if I take all these things, plug them in the Pythagorean theorem, we would have a squared, which is 9 squared, plus b squared, which I don't know, equals c squared, which is 15 squared. 9 squared is 81, plus b squared, 15 squared is 225. And like the last one, to solve for b, we first need to solve for b squared. So if I subtract 81 from both sides, we would get b squared equals 144. Square root both sides, and we would end up with b equals 12.